Welcome. In your readings, you explored the concept of inheritance a little deeper, and we can use our payroll program as a example of how to get started here. Um, what we've done is created a brand new class called person, and person contains all of those things in it that we feel are consistent with all persons. Anything that would fall into that category. Persons have a first name and a last name, and our persons have a means of getting the full name, as we have on line 28. Now, those are the things that all of the people that we expect to deal with have in common. We want to specialize on this because some people are employees. Now, I have a little further down specification of becoming more specific about the usage of the class. And in here, we're adding all of those things that make a person more specialized as an employee. So we're not repeating anything. We're just simply adding to. The extends allows us to acquire everything that would be in the person superclass. So now I have a more complete picture of useful inheritance. Now we have our normal run-of-the-mill constructors, and we also have all of our other getter and setter methods. And then finally, at the very end on line 50, we have our get pay info as before. So the only thing we did in this case was strip out the first and last name and all of the associated behavior for it and placed it in person. Now, why did we bother doing that? What happens if I have another kind of person that's not an employee but figures in my program? Let's say, for example, I have a dependent. Now, a dependent is a person, but it's not an employee. So I get double usage out of the person class. I don't have redundant code. One of the best practices that we would like to approach is a single point of maintenance for our programs. Right now, we would have that. If person needs to change, we change it in one place, and then all of the classes that are derived from it wind up being changed as well. Our program that handles our employee doesn't really change much. And here we just simplified it to get the first name, get the last name. But the user interface here for the program looks pretty much the same as it did before. So our reorganization of the employee really didn't do anything on this end of the program. And this is a nice thing we've separated tiers, the input and the business logic from in our application. We can go into one other example for this, and we can look at two classes that are being created. In this source code, the demo, we have a MyBase class. That's defined on lines 1 down through line 12. Following that is a MyDerived, and that extends the base class. And that goes from line 14 down to line 30. The main method here for the program, inheritance 1, it will create an instance of MyBase, and he's calling it B. And then he's going to show B. Then he's going to create an instance of MyDerived, and then he's calling show. And that is, of course, the MyDerived class's show. We notice that each of the classes lines 26 to 29, for example, is the MyDerived definition for show. And we have another one on lines 9 through 11. In essence, the MyDerived class, by redefining show, overrides the show that is been defined in the superclass. So, let's go back down to the main. In the main portion of it, where we have on line 35, we have b.show. Because we're going directly to the base class, MyBase, what we'll show there is the method, the show method being called will be the one associated with the base. Below, we can see we're creating a MyDerived. And in there, d.show will use the derived method that we had placed in the, that we defined in the MyDerived class. No surprise there at all. Let's take the example a little further. And in this example, what we see is that we have a main method for inheritance 3. It's using the derived classes that we have just created in the base classes. On line 3, we're creating a brand new derived class. But notice, on line 4, we're taking the derived class and assigning it to a base class. Well, the question, of course, is that legal? Because the derived class contains enough information to populate a base class, it's totally legal. What we will get is availability to only those members, however, that are present in the base class. Here's an interesting portion of it, though. When I run the show methods on lines 5 and 6, something unexpected happens based on what I had just told you. On line 5, we see that we're calling the base class's show method. On line 5, we have a method call to the show method that's a member of base. Remember, right above it, what we had done was assign that base, however, the value of the derived class. And immediately below that, that show method that we talked about on line 6, we have the same thing, except now we're making a direct call to the derived class. Now the question, of course, is what shows up? Which show is actually going to be performed for which version that we have on 5 and 6? The answer is that they're both the same. By assigning a derived class to a base class, we call, that's basically an implicit cast. We're allowed to do it simply because we have enough information to fill in the superclass from its subclass. It's also considered an upcast because we're upcasting to the more general items in the inheritance tree. So by doing what the assignment that we did on line 4, we have created and overridden the show method that happens to be in the base class. So it no longer is in operation. We can call it. We can call that base, the base from here, but we'd have to use the dot, the super dot parameter or operator, if you will, keyword, in order to do it. So both of these do exactly the same thing. The show methods will be identical between the two. Now, this is an important concept. If you think about it, what we're doing is hiding the exact data type of my derived class and looking at it as a more general class. Let's assume I have an awful lot of types of classes, my derived class, or my derived 1, my derived 2, my derived 3. And each one of them has their own show method. And we know that an array can only contain the same data type for each cell. Well, if we use this logic, what we could do is implicitly cast all of those different derived classes to a central data type, namely base, because they'll all inherit base. And they can, the base can be assigned as a consistent data type in our array. Now, that's an important concept. Working toward a more generalized, or let's use another word, abstract version of a class. The only rule that we have is anything that was defined in the myDerived class that was not defined in the base class is going to be unavailable to me as long as I'm dealing with it as a derived class. So in this case, I have access on line 5 to the show method because it's defined in the base class. And I also have it available in the derived class because it was assigned or made available through the base class. All right. There's a lot in this conversation about inheritance. It's a very important concept in object-oriented languages, regardless of which language you choose. Java relies on inheritance quite a bit. But here's a best practices concept that's kind of becoming the rule of the day. As nice as inheritance is, we should be very careful when we apply it. A program that builds very big inheritance trees can be more difficult to maintain than a very small inheritance tree. So how do we manage that? Well, if a class contains members, variables that are assigned other classes, we can usually get pretty much the same effect and still get the values that they offer up. So the rule might be, as long as classes are directly related to one another, such as the way that our previous example of person was directly related to an employee, and in fact, an employee would probably never exist on its own, inheritance is a natural thing to do. But when we were working with some of our other examples, we used, for example, the random class in order for us to randomize a numeric value in a lot of our previous examples. It doesn't make sense for our class to inherit random just simply for that purpose. We're going to be using one of its methods as a utility. We'll be derive the value, and then our interest in it goes away. So inheritance there is just obviously not an appropriate thing to do. Okay, your next reading that we'll be moving on to is going to talk about your access to these various classes that are playing the role of superclass and subclass. So have a good time, and we'll talk again.